Hello students, welcome you to this video. We are studying sums in probability, right? Few more sums we left out. We are going to continue that. Now, exercise 8.4, question number 9. 3 unbiased coins are tossed. 3 unbiased coins are tossed. So immediately you know how many sample points you get, right? 8 you will get 2 raised to 3, 8. What are that 8? Starting with H you write 4, right? HHH. HHT, HTH, HTT. Then wherever H comes, you put T, and for T, you put H. So TTT, TTH, THT, then THH. So N of S is equal to 8. Okay, now please listen carefully. 3 unbiased coins are tossed once. Find the probability of getting at most 2 tails, that is one event. R means you have to find what? Union, right? Or at least 2 heads. So 2 events, we take one event as A, another event as what? B, in between R, so you have to find P of A union B. That's a very simple thing. What is P of A union B? P of A plus P of B minus P of A intersection B. Okay, so we write the steps. So let A stands for at most 2 tails. At most 2 tails. So what's the meaning of at most 2 tail? Maximum 2 tail. It should not exceed 2. So 2 or less. 2 tail or 1 tail or even 0 tail. So which you can take. So except this you can write everything, right? At most 2 tail, maximum 2 tail. So you write HHH, HHT, HTH, HTT, TTH, THT, THH, right? So the favorable 7 cases, N of A is 7. Now, second event, at least 2 heads. So B stands for at least 2 heads. What's the meaning of at least? You're very careful with this at least and at most. At least means, at least 2 means 2 or more. So you can take 2 heads and 3 heads. 2 heads, even 3 heads you can take, right? 2 heads and 3. So these are the 4. HHH, HHT, HTH, THH. At least 2 head means 2 or more. So N of B is equal to 4. Now we find A intersection B. What is common for both A intersection B? HHH is there, yes. HHT, yes. HTH, yes. THH, yes. All these 4 are there also, right? So I write the same thing. HHH, HHT, HTH, THH. So they asked to find N of A union B, right? P of A union B. So but before that you can write N of A intersection B. N of A intersection B is also 4. Now P of A union B is equal to P of A plus P of B minus P of A intersection B. In all the 3 cases, denominator is same. It is what? 8, because totally there are 8 cases. A favorable 7, B favorable 4, intersection is 4. So here 7, here 4, here 4, right? 4 by 8 cancel. So your answer is what? 7 by 8. Question number 10. Listen. The probability that a person will get an electrification contract. So let A stands for electrification. So P of A, they given us what? 3 by 5. And the probability that he will not get plumbing contract is 5 by 8. So B stands for plumbing contract. But P of B is not given, P of B bar is given. Why? because the probability that he will not get, right, it is 5 by 8. So from there you can find P of B. P of B means 1 minus P of B bar. So it is 1 minus 5 by 8. Take 8 as LCM. 8 minus 5, it is what? 3 by 8. So P of A, P of B, you know. Now see, the probability of getting at least one means either this or that, okay, is 5 by 7. So P of A union B given as 5 by 7. At least one, either this or that. Okay, so A union B. See what they asked? What is the probability that he will get both? Probability that he will get both. Both means A and B, right? So we have to find P of A intersection B. This is what they asked to find. So for that, we start with the formula we know. We have the addition theorem on probability, right? So we have P of A union B is equal to P of A plus P of B minus P of A intersection B. P of A union B is 5 by 7 equal to P of A. It is given 3 by 5. P of B, we got it 3 by 8 minus P of A intersection B. Take this minus term here. P of A intersection B is equal to, already here we have 3 by 5 plus 3 by 8. Take this 5 by 7 to the other side, minus 5 by 7. So you take LCM 5, 8, 7, you cannot divide anything. So you multiply everything, you are getting 280. So 280 is LCM. 5. How many times? 56. So 56 into 3. Plus 8, leave that 8. These two, or 35. 35, here we have 3. Minus, here we have 7. So leave 7, take the other two. 40, right? 40 into 5. So you are getting 168 plus 105 minus 200, right? Divided by 280. So the two values, you add it and you subtract the 200, you will be getting 73 by 280. Okay, do the calculations. So you can't simplify, so you can stop here. Now let's move on to question number 11. Please listen carefully this question. In a town of 800 people, so total N of S is equal to 800. 1300 are over 50 years. So let A stands for over. Age is over 50 years. How many are there? 1300. So N of A is equal to 1300. Okay. And 3000 are female. 3000 are female. So B stands for female. So N of B is equal to what? 3000. Okay, 3000 are female. Total 8000, in which 3000 are female. So male 5000, right? Let us see what they asked. It is known that 30% of female are over 50. So female and over 50. Female means it is what? B. Over 50 means A. So both. So A intersection B. N of A intersection B is A and B. Female as well as over 50 years. Both. So that is, they didn't give the number. They said 30% of female. 30% means 30 by 100 of, not the total. 30% of female. Female means how many are there? 3000. So 30% of 3000 are over 50 years. If you cancel 2 zeros, you cancel. So 3 3s are 9. So 900, that is P of A intersection B. So what they asked here, what is the probability that a chosen individual from the town is either a female or over 50 years? So either a female, that is B, union over 50 years is what? A. So we have to find P of B union A. B union A and A union B, both are same only, right? So probability of A union B is equal to P of A plus P of B minus P of A intersection B. P of A, in all the cases, denominator is what? 8000, right? Intersection is what? 900. Intersection is 900. P of A is A 1300. P of B 3000. Right? So 8000 is LCM. Don't, okay, if you want, can cancel two zeros, right? Here 2 zeros you cancel. Here also 2 zeros. Here 2 zeros cancel. 2 zeros. Here 2 zeros, 2 zeros. That's all. Now it is what? 80, right? If we take 80 as LCM, 13 plus 30 minus 9, right? So 13 minus 9 is 4. 30 plus 4, it is 34. 34 by 80, if we cancel 2 tables, 17 by 40. So the conclusion you can write, therefore the probability of selecting a female or over 50 years is equal to what? 17 by 40. Okay, now let's move on to the next question, sum number 12. A coin is tossed thrice. So immediately you know a coin is tossed thrice means you know sample space 8, right? HHH, HHT, HTH, HTT. Then TTT, TTH, THT, THH. So n of S is equal to 8. Now please listen very carefully. A coin is tossed thrice. Find the probability of getting exactly 2 heads. A stands for exactly 2 heads. Exactly 2 heads means you can't take this. Here 3 heads, right? Exactly 2 heads. 1, 2, 3. So you have to write HHT, HTH, THH, right? So exactly 2 heads. Or at least 1 tail. So B stands for at least 1 tail. At least 1 means 1 or more. 1 tail or 2 tail or 3 tail, right? 1, 2 or 3 tails. You cannot have at least 1 tail. You cannot have that 0 tail, right? At least 1 tail means you can take 1 tail or 2 tail or even 3 tails. So except that HHH, you write everything. HHH alone you leave. Okay, so HHT, HTH, HTT. Then TTT, TTH, THT, THH. So from that you look and write. Okay, so this is B. Then what is, one more is there, no? Or 2 consecutive heads. 2 consecutive heads, okay? C stands for 2 consecutive heads. 2 consecutive head means you can head, even this you can take. Here also 2 consecutive heads are there, no? 3 are consecutive, okay, 2 consecutive also take. HHT, THH. So these are the 3 cases. So n of S is 8, n of A 3, n of A is 3, n of B is 7, n of C is equal to 3. Now A intersection B, find out A intersection B, B intersection C, C intersection A, then A intersection B intersection C. Why you need all these things? Because the question is, please listen, 3 events in between R, here also R. This is our A, this is our B, this is our C. So A or B or C, you have to find P of A union B union C, the lengthy formula. You are remembering what's that formula? First 3, take 1 at a time positive, next 2 at a time negative, then 3 at a time positive, P of A plus P of B plus P of C, minus P of A intersection B, minus P of B intersection C, minus P of A intersection C, plus P of A intersection B intersection C. Okay, that we have to use. So A, B, C, major thing you got it. Now just to see the intersection. A intersection B. Listen, A intersection B means for A and B, what is common? HH, A is, A has only 3 terms, right? So HHT, yes it is there. HTH is there. THH, everything is there. So all the 3 you can write. So you can write HHT, HTH, THH. So N of A intersection B is 3. B intersection C, same way you find out B intersection C, common for B and C. HHH is not here. HHT is there. THH also there. Only the last two, right? HHT, THH. Only two are there. Then A intersection C. A intersection C. Common for A and C. This is A, right? A and C. HHH you cannot take. HHT, THH. Only that two, right? HHT, HHT, THH. So only two. Then finally we want A intersection, B intersection, C. Common for all the three. Can you find anything? HHT. HHT is in all the cases, right? HHT. Then THH. THH. Only that two common in all the three. HHT, THH. So N of A intersection B is 3. N of A intersection B is 3. N of B intersection C is only 2. N of A intersection C is 2. N of A intersection B intersection C is also 2. Okay, so now we want P of A union B union C, right? The formula P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C, finally plus P of A intersection B intersection C. In all the cases, denominator is 8, right? So now listen, P of A. For A, how many are favorable? 3. So 3 by 8. Plus P of B is 7. C is 3. So 7 by 8 plus 3 by 8. 7 by 8 plus 3 by 8. Minus P of A intersection B. It is 3. So 3 by 8. Minus P of A intersection B. 2 by 8. Minus again 2 by 8. Then finally plus all the three. That is also 2 by 8. So plus 2 by 8 minus 2 by 8 you cancel. Minus 3 by 8 plus 3 by 8 cancel. In all the cases, denominator is 8, right? So 3 plus 7 minus 2, you are getting 3 plus 7, 10 minus 2, 8. 8 by 8, cancel, your answer is 1. Okay, so this is what they asked to find. Now see question number 13. A, B, C are any three events such that probability of B is twice as probability of A. And probability of C is thrice as that of P of A. 3 times as P of A. And P of A intersection B. P of A intersection B is 1 by 6. P of B intersection C is 1 by 4. P of A intersection C is 1 by 8. P of A union B union C is 9 by 10. P of A intersection B intersection C is equal to 1 by 15. They asked to find P of A, P of B, P of C. But if I know P of A, you substitute, you can find P of B. You substitute here, you can find P of C. So main thing we have to find out P of A. So for that we start with the result what we know. So we have the addition theorem. P of A union B union C equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Substitute the known values. P of A union B union C is 9 by 10 equal to P of A, right as it is. P of B can be written as twice P of A, 2 times P of A. P of C can be written as 3 times P of A, 3 times P of A, then the remaining are all given. Minus P of A intersection B is 1 by 6. B intersection C 1 by 4. P of A intersection C 1 by 8. Plus A intersection B intersection C is 1 by 15, right? So now listen how to simplify 9 by 10. 9 by 10 you write as it is. P of A terms if you group, you are getting 6 times P of A. 6 times P of A. Now for all these things you can take LCM. So 6, 4, 8, 15. If I take LCM, 2 table 3, 2, 4, 15. Again 2 table 3, 1, 2, 15. Now 3, 1, 1, 2, 5, right? 6 into 2, 12 into 10, 120. So 120 is LCM. So what you can do, you take plus 120, you take LCM. 120 divided by 6, you are getting 20. So minus 20. 120 divided by 4 is 30, right? So minus 30 into 1, minus 30. 128 is 15, right? So minus 15. Finally, plus 120 by 15 is 8. You will get 8 into 1 is 8. So you are getting, so 9 by 10 is equal to 6 times P of A plus. Let us see, plus or minus, because minus is more. 15, minus 15 plus 8 is minus 7. So minus 7, minus 30, minus 37, so minus 57 you'll get. You can cancel by 3 table, 19 and 40. Bring that negative term to the left side, 9 by 10 plus 19 by 40 equal to 6 times P of A. So here you take 40 as LCM. 40 divided by 4, 10, right? Sorry, 4. 9 4s are 36 plus 19 equal to 6 times P of A. So 6 times P of A is equal to, add these two, you will get 55 by 40. The 6 will come down. So you are getting P of A is equal to 55 by 40 and the 6 has to come down. So cancel by 5 table, 11 and 8, right? So P of A equal to 11 by 48. 11 by 48. So this is P of A. Then they asked to find P of B. P of B is 2 times P of A. P of B is equal to 2 times P of A. 11 by 48. Cancel this 2 table, you are getting 24. So your answer is 11 by 24. And P of C equal to 3 times P of A. 3 into 11 by 48. 3 table you cancel, you are getting 16. So your answer is 11 by 16. So write the final answer. P of A 11 by 48. P of A 11 by 48. P of B 11 by 24. And P of C equal to 11 by 16. Okay, now let's move on to the last question, that is sum number 14. In a class of 35, so you know n of s is equal to 35. Students are numbered from 1 to 35. Suppose you assume in your class there are 35 students, the roll number 1, 2, 3, etc. up to 35. The ratio of boys and girls are 4:5, right? Boys is to girl equal to 4:3. So total ratio 7. So number of boys equal to total ratio 7, boys 4. So 4 by 7 into the total. So cancel. So 20 boys. Out of 35, 20 boys, then the remaining are girls, right? So number of girls equal to 35 minus 20, it is what? 15. Or 3 by 7 into 35, okay? So now, how they numbered, you know? So for the boys, they numbered, so that you see the roll number of the student begin with boys and end with girls. So first for all the boys they are giving numbers. How many boys are there? 20 boys. So for boys the day number like this 1, 2, 3, etc. up to 20. For girls it starts from 21, right? 21, 22, it goes up to 35, right? Because total. Yes, 20 boys, 15 girls. Okay, now please listen. Find the probability that the student selected is either a boy with prime roll number. So A stands for a boy with prime roll number. So can you find prime numbers in boys? So 1 to 20, you write down the prime numbers. 1 is neither prime nor composite. The first prime number is 2 only. So the prime numbers are 2, 3, 5, 7, 11, 13, 17, 19. So there are 1, 2, 3, 4, 5, 6, 7, 8. So n of A is what? 8. Or selected is either a boy with prime roll number, that is A, or means union. A girl with composite roll number. So B stands for girl with composite roll number. So numbers which are not prime are composite numbers with composite roll number. So girls number starts with 21. You write down all the composite numbers. Leave the prime numbers, you write all the remaining, right? So 21, 22, 23 is a prime number. Don't take that. 24, 25, 26, 27, prime number only, not prime number, divisible by 3 and all, right? 28, 29 is prime number, leave it. 30, then 31 is a prime number, don't take. 32, 33, 34, 35, right? So n of B is equal to, you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Don't stop, still one more event is there. What's the next event? R, once again. So A union B union C, right? And even roll number, they didn't say even prime number. So C stands for even roll number. Maybe a boy or girl, whoever it may be, the roll number must be even roll number. So all the even numbers 1 to 35 you write. So 2, 4, 6, 8, 20, then 22, 30, 32, 34. So 17 you will get here, right? N of C is equal to 17. Now all the intersection also you need, right? So now I want A intersection B. See what is A intersection B? Intersection common for A and B. 21, 22, 24. So B we have composite number. A we have prime number. So nothing is common for A and B. So A intersection B is empty set. A intersection B is empty set. Okay, so you write like this or you can use this symbol. Okay. So n of A intersection B is 0. N of A intersection B equal to 0. Now B intersection C you check. Common for B and C. 20 after 20 you check, right? 22, 24, 26 even numbers. From here you take all the even numbers. 22, 24, 26, 28, 30, 32, 34, right? 22, 24, 26, 28, 30, 32, 34. If you count, you are getting n of B intersection C, you are getting 7. So now A intersection C, common for A and C. Please listen, C is all even number. A is this. Common means only that one even number. Okay, so 2 is the only one number. So n of A intersection C is only one number, right? Now for all the three, A intersection, B intersection, C. For A and B itself, nothing is common. So what is common for A, B and C? Nothing. So that is also empty set. Okay, either use this symbol or the phi. So now we want n of A union B union C equal to the formula n of A plus n of B plus n of C minus n of A intersection B minus n of B intersection C minus n of A intersection C, finally plus n of A intersection B intersection C. Substitute. In all the cases, denominator is 35, right? N of A is 8. So 8 by 35 plus n of B. So B is 12, C is 17. So 12 by 35 plus 17 by 35 minus A intersection B 0. So 0 by 35. B intersection C we have 7, right? So 7 by 35. N of A intersection C only 1. 1 by 35. Finally plus for all the three it is 0. So 0 by 35. So n of A intersection B intersection C is what? 0. So LCM you take 35. 8 by 35 minus 7 minus 1. That is minus 8 by 35, right? So 8 plus 12 plus 17 minus 7 minus 1. Minus 7 minus 1 is minus 8 plus 8 cancel. So you are getting 29. 29 by 35 and that is your final answer. Okay. So that's all the example sums. Exercise sums we finish. You go through the example sums. So we'll continue the next video.